Yeah, Ganesh. So Manoj here, like I have total 12 plus years of experience in IT. So currently I'm working in a data engineering platform only. So like I am mostly into an on-prem. Okay, so like Hadoop, Spark, Hive, like that. Okay, so I just want to move into a cloud platform. So that's why I'm opting for this training session. Ganesh, the short info.
Thank you. Shivam, Shivam, can you brief about yourself? Jaisurya.
Hi sir, this is Jay Surya. Presently, I'm studying BTech 4th year at JNTU Vijayanagara College, and I am interested in data engineering.
Okay, got it. Yeah, you can go ahead. Meanwhile, other people are joining. Since many of them they're busy with meetings, so they'll join in between.
Sure, Ganesh. Thank you, everyone, for your quick brief or introduction. My name is Aditya. I am a senior data engineer and working as architect. So my expertise is around data engineering, primarily into AWS cloud stack. I have experiences in GCP as well as in Azure, but my primary cloud stack is AWS itself. So I have experience in big data pipelines. I have experience with building serverless architectures, micro batches, frameworks, and complete autonomous applications that can run on the fly on clusters without need of any manual intervention. So that's a quick about me. I have 8 years of experience in this specific domain of data engineering. My experience varies from on-premise solution like Informatica and other ETL tools, and now primarily into AWS itself. So that's a bit about me. So let's get started on the session. Let me share my screen and then we'll start. Okay. So I am sharing my screen. Let me know if this is visible to everyone, and then I can get started.
Yeah, yes, Aditya.
Okay, perfect. Thanks you so much for confirming. Let me take into sliding mode. Okay. So welcome everyone to this data engineer based on AWS Cloud Tech Stack training course. So in this course, we are going to understand more and more about data engineering, and we will more, deep dive into how exactly data engineering is performed using the AWS platform. But before we, move on to the course structure, what we are going to provide you, I just want to highlight what exactly data engineering is all about, right? So, in a nutshell, whatever work we are doing till now, in a way, is also data engineering. If you are building a pipeline, if you are moving data from one place to another, if you are reading a file and then loading it into a database, all of these activity is somehow part of data engineering. But data engineering is a very big and vast subject. It encompasses these things that I mentioned, and it encompasses more things that I'm going to talk about in couple of minutes. So first of all, let's try to understand what exactly data engineering is. As I said, building and maintaining infrastructure for the storage of data and then processing it efficiently so that meaningful information can be derived out of my data. This whole process is called data engineering. Being as a data engineer, the responsibilities will lies on our shoulders are how we are going to collect the data from various sources, how we are going to process the data, how we are going to load the data back to any target. Target can be a file for me, target can be a table sitting in a database or a data warehouse. And what is the importance of data engineering, right? So it enables us to take more informed decisions. It enables to run data science, machine learning, AI, and overall it improves the performance and agility of our business processes. I'll take one example. So let's take a step back in 10 years, right? So before 10 years, how much data we as humans or machines are generating. So today is 2023. 10 years back in the year 2013, how much data we would be generating. So there is a statistic published by Statistica, which says that the amount of data generated in a year back in 2013 is equivalent to the data that now generated within a single day itself. So you can imagine how much the data has grown significantly. And this data comes in various shapes. When I say various shapes, what exactly it means? So data can be in a form of files, right? The normal CSV or text files. The data can be in a form of a JSON structure, which is semi-structure in nature. JSON is a dictionary, right? So it can be in a form of an XML, or nowadays, right, with the growth of social media and online platforms, the data is now taking a new shape, and that shape is nothing but videos, audios, text, photos, right? So all of these information is nothing but data to me, right? So we have big social media giants like Facebook, Instagram, Twitter, which is now known as X, right? Other than that, there are other social media platforms. So they generate huge amount of data in the form of photos, videos, messages, text, chats, right? And eventually this data is being utilized. This data is being monetized, and you will see lots of ads running with the help of this data, right? So if you are interested in a specific type of subject, then on social media, you will see same ads shown to you with your interest altogether. How this ads management runs, what technology is used in the backend, all of this is happening with the uses of data engineering. Data engineer builds such powerful, scalable solution that can handle petabytes, terabytes of data to be processed in real time, and we can generate more meaningful information out of it, right? So what are the challenges that data engineer generally faces, right? So nowadays we can use any tool or say build any solution. So when we built that solution back in 2013, 14, 15, any pipeline, we were assuming that the data size will be of 10 terabyte. 10 terabyte is a very big number. But with the growth in the data size become very huge. And that solution that we built was not that stable to handle. So we have to build solution being as a data engineer that are scalable in nature, that can handle huge amount of load coming in from the inputs. We as a data engineer need to work on real-time processings. What means by real-time processing? Meaning as soon as somebody provides any input, I'll take the same example of social media. As soon as we upload a photo on the social media platform, our friends get notified in real time that, hey, your friend has uploaded a photo. The friends can come on the social media platform. They can see the photo. They can either comment on it. They can like it, dislike it. They can do whatever. As soon as they comment, like, dislike, in real time, we receive started notification. Hey, your friend has actually commented on this. Hey, Your friend has liked this. So how exactly this happened? And we as a data engineer, how we are dealing with this type of scenarios, right? So this is all we as a data engineer need to manage. I'll take one example of the real-time data processing, the real-time data driven decisions that we have to make with the help of data, and being as a data engineer, what we need to do. Let me, walk you through one example. Okay. So all of you may have heard about Twitter, right? So Twitter is a platform which is used to share our opinions and views. And whenever a person post something on Twitter, this will be called a tweet, and anyone with access to Twitter can react to that tweet. When I say react to that tweet, what exactly it means? They can either like it, they can comment it, they can retweet it, they can dislike it, right? They can perform bunch of operation. So nowadays you have seen that lots of companies, lots of big personalities have very active on Twitter, and they track whatever the audience are interacting with the post. Meaning, let me take one example. There is a popular figure called Elon Musk, right? Everyone knows who is Elon Musk. He is the founder of SpaceX. He was the founder of PayPal. Now he's also owner of Twitter, right? So what Elon Musk do? He basically share his opinion very actively on Twitter, right? So he talks about green energy, he talks about US governments, he talks about policy, he talks about Tesla, right? He talks about bunch of different topics. And he takes Twitter very seriously. How the people react to his opinions or say his question, he performs his task basis the audience opinion. For example, on Twitter, Elon Musk asked, should I change the name of Twitter from Twitter to X? The audience majorly say yes, please go ahead. And then on second day itself, he changed the name of Twitter to X. If you Google, now the name of the Twitter is not Twitter anymore, it is X, right? So what exactly happened in the backend? How exactly he come to the conclusion that everyone is in the favor of changing the name to Twitter by just posting his question and then analyzing the user opinions? How exactly this happens? Let me give you one quick example. So let's say Elon Musk perform a tweet, right? So this tweet is about, say, Tesla, right? Similarly, Elon Musk perform a tweet about any other topic, say US policies. Policies. Similarly, he did a tweet with respect to moon mission, right? That India performed. Correct. He did these three tweets. Let me move this out here. Okay. So on these tweets, people can react, right? So react means they can either comment, they can either like it, they can either dislike it. For the quick demo purpose, right? I am going to use the concept called like, dislike, and no comments, or say neutral, right? So for me, say this is a symbol of right? So this is for, let's say, people are treating this tweet in a positive manner. Say, imagine this is a symbol for positive, or let me use a different symbol. Positive. Okay. So this is a symbol for positive, meaning people are taking this tweet in a positive manner, right? People can, vote negative. For negative, they can, choose this symbol. And for neutral, there is like, they can, choose this icon, right? So for moon mission, on his tweet, people have given these responses, right? So he has received couple of pluses and one neutral, right? Plus means positive response. The circle means neutral response, and the minus means the negative response. On US policy, he received negative responses, and on Tesla, okay. So if I ask you to find out what is the sentiment of users or say audience on the first tweet with respect to moon mission, with respect to this thing. So can anyone on the call tell me what is the sentiment of the audience on his tweet? Is it a positive sentiment? Is it a negative sentiment? Or is it a neutral sentiment on this tweet?
Positive, right?
Yeah, it's positive. And why? Your answer is absolutely right. But what is your thought process?
I mean, you got the three positive responses. So
Absolutely.
majority of the response.
Absolutely right. Because the responses are positive in nature here. And we can conclude that it's the sentiments of the audience is positive on this tweet. What about the second one, the Tesla tweet one? How is his sentiments is? Circle represent neutral, the minus represent negative, and the plus represent positive.
Neutral.
Neutral. Perfect. And what about the third tweet?
Negative.
Negative, right? So it's very easy by just looking at this image here to find out the overall sentiment of a tweet. Imagine in real world how exactly things happen in Twitter. We don't have these plus, minus, and neutral buttons. We have only like button. We have only comments section, right? There is no dislike button. I believe. Correct me if I'm wrong, if I'm mistaken. And there is no neutral button for sure in Twitter. So now we have to analyze in real world. We have to analyze. So what people does is people basically write comments, and in comments they mention they are happy with this approach, they are not happy with this approach, they are okay with this approach. So in reality, if we have to find out the sentiments of the user on Twitter, we have to understand the text or the comments written on that tweet. And that reading and the sentiment analysis of that comment needs to be happen real time, because as soon as Elon Musk posts something on Twitter, he wants to see in real time how his tweet is performing. Is it either it is going up or say it is going in positive direction, either it is neutral, people are perceiving it as neutral, or people are treating it as negative. So this is a use case of data engineering, right? So being we as a data engineer, we have to handle this use case of finding the sentiment of user and give back the overall response of his tweet. So we as a data engineer need to process this data. For that, we may utilize a service that fetches the tweets in real time from Twitter, right? We fetch this information, give it to a service that we as a data engineer will build. This service will analyze the information available on tweet. It can analyze the likes, it can analyze the comments, and basis that it will generate a score, say positive, negative, and whatever, and then it will show it as the overall result back to Elon Musk. Let's say this is Elon Musk and this is giving the overall score, overall score, right? So if the score is positive, it means that the tweet is perceived in a positive manner. If the score is negative, then the tweet is perceived in a negative manner. So this use case, this complete use case that I mentioned is an example of data engineering pipeline that we have to build in real time, being as a data engineer, and you can now understand the complexity behind it. But guys, don't worry, as we move along in the course, in upcoming sessions, I am going to talk about each and every intricacies of handling such complex real-time pipelines. In the course, I am going to talk about how exactly data engineering will be utilized in building these pipelines, how we are going to handle real-time data. So how we are going to access the messages in real time with the help of Kafka, with the help of other streaming services, and how we are going to process them and generate analytics out of it, right? So this last step, which is overall score that we are generating, is nothing but analytics that we as a data engineer needs to perform. If I go back now again to my slide, in my slide, I was talking about in the data engineering definition, we have to collect data. So collection data means collecting the tweets. Transformation means performing the sentiment analysis and then storing it somewhere, right? Or generating the score. So you can see that we can perform data-driven decisions, meaning coming back here, if Elon Musk says, I am introducing a new model in Tesla, and I want to take your opinions. If people are reacting neutral or say positive, then Elon Musk for sure know that, hey, people are loving this new model. We can release it out, right? So this enables Elon Musk to take meaningful business decision out of what he was trying to launch, right? So this is what data engineering does for Elon Musk. Had not been the complex data engineering pipeline built, will this guy be able to understand millions and you know uh, couple of thousands comments and likes, right? He as a user cannot read billions of comments appearing on his tweet, right? So we need complex data pipelines, data engineering stuff to handle such things, and we can generate more meaningful information out of our data, right? This is one just basic example of data engineering pipelines. There are big better examples available, but just to try to show the importance and intricacies of data engineering, I thought of giving you one basic example. I'll quickly move back to my slides. Now we understand that what exactly data engineering is, right, in a nutshell. For doing data engineering, we would be utilizing Amazon as our cloud provider, which is nothing but AWS. In AWS, we would be using S3, we would be using Spark, right? Redshift, Airflows, and couple of other tools to perform the data engineering. As I move along, I want to also touch base on what exactly cloud means, right? So we have understood so far that what is data engineering, but now let's try to understand what cloud is. So everyone on the call may definitely have heard about the term called cloud, right? And most of you may also be knowing what exactly cloud is. But just to reiterate one more time, cloud is not this picture that is, with this cross icon, right? This is also a cloud, but this is not the cloud that we are going to talk about in our upcoming sessions, right? Cloud is something which is on the second image. It is nothing but a set of big machines available in a secure building through which we can interact and build and store our data. So one basic example of cloud is Gmail and Google Drive. Everyone on the call, I assume that have one way or the other interacted with Google Drive. So with Google Drive, we can seamlessly access our data no matter where we are, no matter which device we are on. So let's say I have a Google Drive account. I can upload some photos, videos from a phone. Now I want to access this information on a laptop. I can do that. What I need is just the Google Drive account ID and password. So that's the beauty of cloud. You need not to have all the system available on a single platform. You can access it anywhere from any device with proper set of user ID and password access you have, right? So now coming to the importance of AWS, right? This course is based on AWS. So I want to emphasize why exactly we want to learn AWS. So this statistic is coming from Statista. Statista is one of the leading statistic company that collects a lot of information around the world and then generate these numbers. So this information is coming from the last survey done on Q1 2023. And as per the last analysis, what they have observed that AWS is leading the cloud market with 32% cloud share, followed by Azure, followed by GCP, and then we have other bunch of cloud service provider, and they have this amount of presence in the cloud. So it's very evident why we actually want to learn cloud on AWS, because it's the leading cloud service provider today in the space of cloud technology, right? So what exactly AWS cloud computing is all about, right? So AWS cloud computing, as I shown in the previous figure, is nothing but a set of big computers that are not in front of us, right? But the computers are available on the internet and we can access the information over the internet through these big computers, right? So what cloud offers is it offers a lot of different services. Like we can store a lot of data in our cloud. We can run a lot of programs. We can do a lot of complex activities on the cloud, right? So instead of buying our own computers, we can rent the services of AWS whenever we need them and we can pay them whenever we want. Okay, on the similar lines, I want to give you one example. Let's say you are planning a trip to a country, right? Country outside India, of course. So this trip will be around 15 days. And while planning your trip, you understand that or you realize that you are going to travel from one place to another once you reach that country. So your plan throughout the 15 days is to roam around the country and seize the different places or parts of the country. For roaming around, what you are thinking is, I should be having a car and I will use the car to, move from one place to another in that country. Okay. So you are going for 15 days only, right? And what you understood that you need a car to travel from one place to another in that country. Like you will take flights and plane from India to that country. But once you reach that country, you will require a car to move around, right? So there are two options. Option number one is once you reach that country, you can buy a car over there, right? Once you buy a car, you have to take, licenses, you have to pay registration fees, and you have to do everything for 15 days only, right? So that is one way. You can, ride a car. You have to purchase it and then you can use it. Other way is there is a renting company in that country. They rent car on per day basis, meaning how many days you want to use the car, you have to pay for the amount of usage or amount of days you are occupying the car. Meaning, if you are using the car or riding the car for 15 days, you only have to pay the price for that 15 days period. You need not to pay the price for whole month, whole year, or for the full car. So which option generally, being as a traveler, you would like to go with? Either with option number one, where you are buying the full car, or either with option number two, where you are just renting the car for a couple of days, using it. Once your task is done, handing over the car back to the owner and giving or paying the rent for that car for those days. Which option would you be going with? Anyone on the call would like to take a stab on this?
mean, we want to like pay only for what we are going to.
Correct. Absolutely right. Right. We are not fool enough. We don't want to pay for the full amount of the car, and the restriction is that we cannot take it back. Right. We cannot take the car back to our home country. The car will be there only. Right. So the good option or the smart option here is to go with the renting option. Same concepts apply in cloud computing. Imagine there is a requirement came to the organization that they want to run a complex analysis model. For running the complex analysis model, they require 100 GB RAM, they require 10 terabyte of storage, and they require some other GPUs, right? So everyone have access to laptop these days, right? So we know that what is the general configuration of our laptop, right? A laptop that comes with 16 GB RAM and with 1 terabyte of space, we know how much it cost, correct? Here I am talking about 100 GB RAM, 10 terabyte space, which is SSD, and I'm talking about high GPUs. And I need this type of machine to perform my high complex analysis. That is part of my project requirement. And this analysis needs to be run for 2-3 months, not more than that. Post that, the requirement is likely no more, right? We are done with our analysis and we just want to perform the analysis for this duration. For this matter, we can, either buy the servers, we can do everything in-house. When I say in-house, mean we can buy a computer machine that is powerful enough to perform this kind of analysis. Buying the machine itself is a very costly job. On top of that, we have to manage the machine. We have to hire someone who know how to manage the machine, meaning the installation of that machine. Then we also need to worry about security. We need to worry about the maintenance of the machine, right? We need to worry about the electricity that the machine is going to consume. We need to worry about the the heat it is going to produce. We have to keep it cool, so we have to keep it in a cool environment. We have to provide good amount of you know uh, cooling capacity to the machine. So we have to work a lot of things in order to manage that machine on our own. We can do that, right? Everything is possible. People are doing it, so this is doable. But the amount of investment that we are going to make in this kind of work is very huge. So there is a second option here, and that option is provided by cloud providers, say AWS. What AWS says is, hey, you can come to me. I have huge space, huge amount of RAM available. Whatever you need, I will give back to you. You ask 100 GB, I will give you 200 GB, right? But what you need to do is, you need to just pay me some rent for the time you are going to use my machine. You need not to buy it for the whole year. You just pay for each second uses. I am not, going to charge you even 1 second more. If you, let's say, finish your work in 29 days, I'm going to take money for 29 days only. I'm not going to charge you even for one full month. How much you are going to use? Pay me that money. No bond, no upfront fee, no registration, nothing. Just pay me for the uses of whatever you want to perform, right? So this is the second option. Earlier, without the cloud, people were going with the option number one. They have to manage everything on their own. There was nothing available for them, right? So they have to take headaches of managing server. They were taking headaches of managing security. They were hiring people to manage all these servers. There are a lot of things that people have to manage or the organization have to manage. But now with the emergence of cloud, people are going with the option number two. They are just renting the servers. They are renting the cloud services for their usage. How much they are using, they are just paying for that money, and hence they are saving a lot of cost. In turns, they need not to worry about the security, they need not to worry about the maintenance, they need not to worry about the people managing these servers. Everything AWS will take care of on its own. We need not to worry about. Now what we need to worry about is just doing the analysis, right? So we only need to perform the analysis, and every other thing will AWS will manage. And that's the beauty of cloud computing, right? So with AWS, it can handle a lot of programs. It can handle a lot of application. Reason because it has wide amount of cloud services or say cloud compute available. We can quickly go in, start creating our account, and then start working on AWS. There is no commitment, no upfront fees required. Whatever we are using, we are going to pay that much. And with the help of cloud computing, even the small businesses that doesn't have that amount of budget to buy servers, hire people, they can quickly start building their projects. They can quickly start building their solution on AWS. They just need to pay whatever they are using. So that's the beauty or the importance of cloud computing is all about. So having said that, we have discussed so much about AWS, we have discussed so much about data engineering. So what is exactly available in the course that is important for you, right? What exactly we are going to talk about? So we are going to talk about the basics of SQLs and Python. We are going to cover Spark and PySpark. We are going to talk about major important services of AWS that are utilized for doing data engineering, that is very helpful in the life of a data engineer. So these services are S3 Bucket, Lambda, Kinesis, Redshift, Glue, Athena. Not only that, we are going to talk about all these services, their demos, how we are going to use it. I am going to talk about the complete overview of these services, how we can utilize these services to build complex data engineering pipeline in real world. Not only that, I am going to talk about the real-time case studies that are available publicly. So we are going to discuss those projects, those real-time case studies, which utilize AWS services to perform data engineering. Right. So here I have mentioned down what all we are planning to cover as part of the course. Like in detail, we are planning to cover SQL and Python, then Spark, then PySpark, followed by PySpark. We are going to talk about Airflow, S3, after S3, Kinesis, and Kinesis is very similar to Kafka, right? So it is used for doing the streaming or building the streaming pipelines. So we have this as part of our course. We have Lambda. Lambda is very important to understand as one of the service of AWS. It is highly used and highly demand service of AWS, and data engineer use it very heavily. Then we have the data warehousing concept that we will understand with the help of Redshift. Then we have Glue, Athena, right? So post Glue, Athena, we are going to talk about AWS integrations and use cases, how exactly these integrations or say different services come together to build a complete data engineering pipeline on cloud stack, right? Not only that, we are going to talk about case studies, real-time projects. Apart from that, we are going to help you with mock interviews. And every week you will be given practical assessment, whatever we have discussed in the sessions in that particular week. We are giving you assessments so that you can practice and understand more about the service or say the topic that we have discussed. And then we are going to talk about the case study. This is a detail of the case studies that we are going to talk about. And with this, I'll conclude my theoretical demo of what we have planned for you in the session. Now, I'll want to show you one quick real-time data pipeline, right? It's a very minimal, very basic pipeline, guys. But I just want to show you the capabilities of AWS, how exactly we can build real-time data pipelines. So in this pipeline, I'll create a message, and message is nothing but say event or say take the example of tweet. So I'm going to write a tweet, and this tweet I'm going to read in real time and process it in real time within a couple of seconds. That's it. So let me quickly open my AWS console. So this is my AWS console. Here I'm going to publish a message, right? I'm just writing the subject for the message, and in the message I will write, this is a demo message for data engineering use case, right? I'm just writing a basic message here, or let me do that only.
Aditya, so what service are you using now?
Uh, so I'm currently using an SNS here.
SNS, right?
Yeah. So I have just published this message. Now I will show you what exactly I am doing. I'm just processing this message, meaning I'm just reading this message out here, right? I'll quickly show you. So what I am utilizing here is a Lambda function. So with the help of Lambda function, I am reading this message and then I'm processing it, right? So in Lambda function, whatever we do, we see the logs. So what I am doing, I am just opening the logs of my Lambda, and this log you can see is just now, right? This log is just created now, meaning that in real time I am getting the information and I am processing the information. Let me open this log to show you what exactly this log contains. So through a different AWS service, which is Lambda, I am reading this message and processing it. So as soon as this log open, I'll show you what exactly we are getting, right? So if I open my log, I can quickly show you that we have successfully passed our message, right? So the subject of our message was test subject, and the body of the message was this is a demo message, right? This is what we have sent in real time, and this actually got processed in real time, right? So this is one basic, simplest example of real time data engineering pipeline. I know this is not the complete example of data engineering pipeline, but just to showcase the capabilities and the power of AWS in quick in, few seconds. This is one of the best example I can come up at this moment to show you how powerful AWS is. I haven't touched my Lambda, right? I just published a message here, and this message automatically read by Lambda and it got processed, right? So now I can do anything with this information. It's a dictionary, right? So with this dictionary, I can do anything, and then using this information, I can either write to a table, I can either write to a S3 bucket, which is nothing but a file, or I can start processing it through different data engineering pipeline as well, right? So this is one of the basic and simplest streaming use case that I can demo at this moment, considering the limited amount of time. But this is one of the beauty of AWS, that everything happens in real time. We need not to worry about what exactly happening in the backend. We just have to use the services, and then we can reap the benefits of cloud computing. Yeah. So with that, I'll quickly conclude my demo. I'll take a pause to see if there is any question on the call by the audience.
Hi, Aditya. Like, thanks for your demo session. So, a quick question, Aditya. So whatever you have shared, right, services, list of services, that is what we are going to see, or I mean, other than that, we have few services like DynamoDB or DS, other things. So that also we will be covering as part of this time.
It's a very valid question. Thanks for raising it up. So whatever services I have mentioned, we are going to cover for sure in the sessions. But since this session is in-person session, meaning, right, we are going to do the interaction while doing the sessions. This is not going to be a recorded session that you are going to get the recordings for. So we can on the fly discuss couple of topics depending upon the overall requirement of the participants in the training session. So if, let's say, majority wants to understand a particular topic, we can accommodate that topic in our curriculum and we can deliver content on that as well. So it could be DynamoDB or it could be any other service.
Okay.
Yeah.
Yeah, hi. Actually, I have a doubt with respect to pursuing data engineering with respect to Azure or AWS. In case you could help me on my doubt.
Yeah, tell me.
Yeah,
So,
with
okay, you
respect.
want to understand which is better at this moment, right?
Yeah,
Like whether should be going with AWS or whether you should be going with Azure. So, Ravi, it's a very valid question, and it's also side by side very difficult for me to answer at this moment. Reason because I have shown you one statistic where I talk about AWS is leading the cloud space with 32% share and it's growing. However, Azure comes second on the list, followed by GCP and followed by other cloud providers. But at this moment, if we look at the chart, AWS is topping, right? So what exactly it means that most of the Fortune 500 organization, the top 500 organizations are on AWS cloud tech stack. What it means that whatever job posting they are going to make, they will be on AWS. So if you see 100 job postings, you would find more job postings on AWS as compared to any other cloud provider, right? So eventually our goal from all these sessions is to understand topic technology and then utilize it in our day-to-day jobs, in our day-to-day curriculum, right? So if you are preparing for upcoming interviews, if you are preparing for your existing job, you can quickly see which cloud provider will be utilized more, right, in your job or in your upcoming interviews. So that's what I could say to you at this moment, Ravi.
Okay. Also, I'm close to 4 years of experience actually. Wanted to know how much this would add as part of my experience, this training.
Okay. So the beauty of this training is that I am going to talk about the real use cases, real industry wise use cases. So whenever I'll talk about a service, I am not going to talk about theoretical aspect of a service, say S3 bucket or say Lambda. I will give you what this service means in enterprise, how enterprises are using this service. So that way you can relate and you can build your understanding of service in detailed fashion. And it totally depend upon how quickly you are grasping or how much you are understanding. But in a nutshell, what I can say is that you can add as many years as you want after you are done with the training. I will give you the overall experience of mine, which is 8 years and whatever I have learned so far. I have delivered these trainings to a lot of folks. So I can give you all the experiences, and using that, you can take out and you can showcase back in your resume, right?
Yeah, okay, sure thing.
Yeah, Venkat, you have any question?
Hello, sir.
Yeah.
Hello.
Yeah.
Suppose coming to AWS DevOps is separate tools is there, and AWS data engineering separate tools is there.
That's absolutely right, Venkat. DevOps focus on deployments, majorly on the deployments, right? So DevOps utilizes the concepts of CI/CD and other deployment services. Data engineering works hand in hand with DevOps, right? So data engineer can also be a DevOps engineer, but this course primarily take focus at this moment on data engineering.
Okay. Suppose my colleagues are also they are working in AWS DevOps in that course. Hello.
Yeah.
But they are saying in DevOps are with AWS limited openings is there when compared to data engineering. That's why I am asking.
That's
Which one is
absolutely
more?
right. Yeah. So you will see more openings on data engineering space as compared to other. Even you will find less opening in data science space. Data engineering is the growing or hot topic uh, at this moment, right? So yeah, it's always good to learn data engineering, and it's the right time to start on data engineering. So that's very right. You will find more openings on data engineering as compared to other tech stacks or technologies or say other roles.
Big data is similar to data engineering. Huh?
Right. So whatever we do in data engineering is basically handling the data, and data size these days are very big, and hence big data is part of data engineering by default. And if you have seen the course curriculum, we are discussing the topics of big data like Hadoop, Spark, PySpark. So this course will cover all these categories.
I have a question. Like, so after this course, so what level of certification we can take? Whether it's a cloud, I mean, we have a different level of courses, right? Like cloud practitioner, solution architect, like data engineer, right? So
Correct.
what level of I mean, what level of certification up to what level we can take?
Okay. So that's a very complex question, Manoj. So this course is basically meant on data engineering. So in this course, we are Venkat, can you please put on mute? I'm getting some noise. Sorry for that. Yeah. So Manoj, this course is specific to data engineering, not to AWS certifications. So in this course, you will find 70-80% topics that will be part of AWS developer and AWS solution architect. Right. So let's say AWS solution architects contains 20 topics. Out of those 20 topics, we are covering 12, but we are also covering additional topics like AWS Glue. We are covering Spark. We are covering PySpark. We are covering Airflow. These topics you will not find in while doing the preparation for AWS certification, say developer or architect. But if you go for AWS specialty certification, which is the next level, right? So there's a level like we start from AWS practitioner, then we have AWS developer and AWS architect, both sitting at the same level. And once we achieve that, we will move on to the specialty. So in specialty, you will find these topics, Airflow, Glue, and other topics that we are covering as part of our program. And since this program is meant for making you aware about the intricacies of data engineering, so hence you will find some topics extra in the course altogether as compared to the certification that you will be preparing, and hence you will find some topic less as well that you will be preparing in your data engineering, sorry, data developer, AWS developer exam itself.
Okay.
Yeah. Any other question? Okay. Thank you so much, everyone, for giving your time on the busy day of Monday. Yeah. Have a great rest of your day.
Thank you. Thanks for your time.
Thank you.
Thank you.
Bye bye.